root function, the parent function, has a point of inflection at 0, 0. And guys, remember the domain and range are negative infinity to positive infinity. Just draw a giant answer to cover both those lines because they're the same thing. All right, I'm going to go ahead and plot the point of inflection right there at the origin. And guys, here's how this works. So again, you got a pattern. You got your sideways, and then you've got your up and down. And just like over there on that chalkboard, like you only went sideways a perfect square amount of times, on this, it's going to be a perfect cube amount of times. And y'all, I wrote that pattern on that square board over there in red. So, but the nice thing, you could plug in positive and negative numbers as long as they're perfect cubes. Negative 8 is a perfect cube. The cube root of negative 8 is negative 2. Same with negative 1. You can multiply negative 1 by itself 3 times and get negative 1. And then, y'all, the positives of those are going to work also. So positive 1 is the root of 1. Positive 8 has a root of 2. So let's go ahead and plot these. These are our patterns from HK. So let's plot these points, negative 8, negative 2, negative 1, negative 1, and then 1, 1, and then don't forget your positive 8, positive 2. And then the best that you can, connect those dots and draw your arrows. So let's talk about point of inflection. Sometimes it's kind of hard to tell for some of us like what the vertex is or the point of inflection. That is going to be where the graph kind of seems like it's a straight line. Right in the middle of where you like see a straight line, that's your HK. So as we move on down, I'll show you and I'll help train you guys on finding HK on these because sometimes it can be a little tricky. All right, so that's the parent function. Let's take a look at some transformations. So over here, we have 2 transformations, guys. It was shifted 1 unit to the left and 3 units down. HK is negative 1, negative 3. And just draw a giant to positive infinity, negative to positive infinity for those last 2 blanks. So let's go ahead and plot negative 1, negative 3. So remember, that's HK. It'll be just a moment. Let's talk about your movement. So remember, sideways and up and down. Negative 8 is going to be sideways movement. And then the root of negative 8 is going to be your up and down movement. So we're going to go sideways 8 and then down 2. Same with negative 1 to the left and down 1 spot. And we can also take those positives. So positive 1 up 1 and then positive 8 up 2. So again, try to draw that curve the best you can, and then that's the appropriate shape for that graph. So for this last one, we have a lot of transformations. We have 4 transformations because remember the negative counts as its own. So for the transformations, we have a vertical reflection. We have a vertical stretch by a factor of 2. And then this graph went 2 places to the right and 4 places up. And we know that the vertex is 2, 4, or HK is 2, 4. And then domain and range, let's go ahead and knock that out. All right, let's plot the HK at 2, 4. And then let's think about our movement. So remember, negative 8, negative 1, 1, 8. And then the sideways movement is negative 2, negative 1, 1, and 8. However, just like with the square root function, all of these are going to be multiplied by your A value. Remember, you never mess with the first column, but the second column is always multiplied by any A value. So we're going to multiply all of these by a negative 2. So this time, when we go 8 to the left, we're actually going to go 4 up because negative times a negative. When I go 1 left, I'm going 2 up, but when I go to the right, now my movements go down. So let's go ahead and plot those. And then kind of draw your shape the best that you can. And then that's going to be that graph. Writing the equation, remember everything's still the same. All the letters. A is still the same. H, K, you still got to find that. So when we are looking at this graph right here, remember to identify HK. It's kind of where it looks like it's in the middle of a line segment. So it kind of flattens out right here, so I know that's HK, and over there is HK also. Okay, so I know that the H value is a 2. I know the K value is a 1. I don't know what the A value is yet. But remember this, and I put it on the post-it because I've been looking at it all day. So to find the A value, guys, I'm going to use the most basic movement. I'm going to go to the right one, and then I'm going to see if I land on it when I move up 1. So when I go to the right 1 spot, if it does not have a stretch or a shrink, I should be able to go up 1 spot and land on it, but I don't. So when I go over, how many total do I climb up to reach the graph? That's your A value. So f of x equals 2 times the cube root. Y'all don't forget to put a 3 in there in that little divot. And then also don't forget to change the 2 to a negative plus 1. That's it. Let's do it one more time. This is going to have a reflection. I know it's going to have a reflection because it's down on the right side of my graph. So again, we're going to find A, H, and K. My H is going to be a negative 1, and my K is going to be a negative 3. So remember, if I did try to move to the right one, remember if it didn't have a stretch or shrink, I was supposed to go up 1, but I can't go up at all, so I know it's a reflection. I have to go down to land on the graph. So I only go down 1 spot, so the A value is just negative 1. That's it. But y'all, when you write it in the equation, don't write the 1, just write the negative. You'll look more sophisticated like that. And then x plus 1 minus 3. That's how you